Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear? Yes. Is my voice clear, audible to everyone? Is my screen visible to all? Right. Okay. Fine. So in the last class, just I was discussing about RTDs, right? Resilient distributed data sets. Spark data objects are called RTDs. RTDs are subdivided into multiple partitions. These partitions are distributed across multiple runs of multiple slave nodes and processed parallelly. Here, the advantage is huge data sets. RTDs can be loaded into RAMs. Here, the advantage is huge data sets. RTDs can be loaded into RAMs. RTD programming style is data flow. Data flow is a sequence collection of pipes. Data flow is what? It's a sequence collection of pipes. Pipes means any data operation, such as loading data, transforming data, filtering data, sorting data, merging. Right? So at each pipe, either transformation or filtering or any operations will be done to the data. In Spark, data flow is executed in sequence, that is RTD by RTD in DAG style with in-memory computing and with persistence feature. Two RTDs can never execute in parallel. Two RTDs can never execute in parallel. That is two RTDs because the output of one RTD is taken as input by the next RTD, right? So here, if you have got flows, right, we have got some common flows. So we need to identify the RTD whose output is commonly used by multiple flows and persist it. So in the previous, in the example, right, R3 output is used by multiple flows. So make R3 as persist. By saying R3 dot persist, it is going to get persisted. So here, no need to execute the flow from the beginning. Here, no need to execute the flow from the beginning. R3 remains in the RAM even though the next RTD is ready and provides its output as input to the next RTD, right? If R3 is not required, then you can forcefully unpersist it by saying R3 dot unpersist. The other situations where RTD gets unpersisted is when server shutdowns or when server is closed and when server shutdowns, right? Yes, right. Okay. Now see that what are the operations we perform in an RTD, right? On a RTD, two types of operations can be performed. First one is transformations. Second is what? Actions. Transformations. First one, if I discuss about transformations. Three types. Transformations are of three types. Each element transformation Example of each element transformation using map or flat map. Using flat map. Each element transformation means example. Transforming each element, transforming each employee name. Transforming each employee name to start with uppercase character. To start with uppercase character and remaining as lowercase. Each employee name to start with uppercase character and remaining as lowercase. Example, rtd.map, right? Yes. Map with some transformation, whether it is transforming each employee name to start with uppercase or any other transformation, right? Next, what is the other kind of transformation is like filter transformation. Example, filter and filter by range. Filter and filter by range. Filter based on city. Filter by range. Filter based on city. RTD dot filter. Aggregated transformations. Aggregated transformations means example, group by key. For groupings and aggregations we use group by key. There is built-in functionalities like reduce by key. We have got group by key, reduce by key. Okay, so first is transformations. On a RTD, two types of operations can be performed. Transformations mainly categorized into three: each element transformation, filter transformation, and aggregated transformation. Second is what? Actions. Second is actions. Yes, 1 second. 1 second. Yes. So on RTD, two types of operations can be performed. One is transformations, other one is actions. Actions means in the last class I was saying until you perform an action, then that entire flow is not going to get executed. There are many actions. There are many actions available. If you perform action, then only the entire flow executes from its root, right? From its root RTD, the existing RTD, right? What are the various built-in actions? Many actions are available. Later I will discuss one by one in brief, but what is an action? When an action is performed, right? When an action is performed on a RTD, then only the data flow, when an action is performed on RTD only, then only the data flow will be executed from the root RTD, right? When an action is performed on RTD, then only the data flow will be executed from the root RTD. The following are some of the actions. The following are the some of the actions. First, collect. Will collect all the partitions data, different slaves of different slave machines into client machine. Example, RTD.collect. Okay, so whenever you perform this action, then only the entire data flow gets executed. The one of the action is collect. Next, we have got the count. Counts the number of elements. Counts the number of elements. In a RTD. Counts the number of elements in a RTD. RTD dot count. RTD dot count, right? Yes, counts the number of elements. Next, take. Takes the first n number of elements, n number of elements in a RTD, right? Takes the first n number of elements in a RTD. Similar to limit in SQL. Takes the first n number of elements in RTD, similar to limit in SQL. ODD dot take of 10. ODD dot take of 10 means takes first 10 records. Means takes first 10 records. If partition 1 is having only 5 records. If partition 1 is having only 5 records, then it takes 5 from partition 1, 5 from partition 2. Okay, now just like a collect, count and take, we have got one more action. Whenever we perform these actions, then that entire data flow is going to execute from the root, right? Save as text file, save as A in uppercase, text file T in uppercase, F file in uppercase, right? Save on text file, save as text file. Yes, if partition 1 has 10 means all it will take from 10 only, right? From partition 1 only. If only 5 available, then where can the 5 should be taken is from partition 2. for storing the results, into a file, right? Just 1 second. Yeah, sorry. Yeah, able to hear my voice? Can anyone please confirm?
Yes.
Fine. So I was just discussing about the various actions, right? So transformations, each element transformations, filter transformations, aggregated transformations, actions. If you perform action only, the entire data flow. Spark is a data flow language, right? So actions like collect, count, take, save as text file for storing the results into a file, into a HDFS file. Okay, fine. At each RTD, right? At each RTD, transformation or filtering will be done to the data, right? At each RTD, transformation or filtering will be done to the data. Okay, for example, val r1 equal to, okay, just observe this sc dot, so RTD1, observe this r1 is an RTD1, r1 equal to sc dot text file, sc dot text file. Okay, sc dot text file, which file, the path you should give, then r1 or RTD1 is created. RTD1 is created. If you load a text file from a path, then RTD1 is created. RTD2 equal to RTD1 dot map, right? RTD2 equal to RTD1 dot map. So map each element transformation, right? Something you can RTD3, right? RTD3 equal to created from RTD2. On RTD2, if you perform any filtering operations, any filter operations, right? Based on some particular condition, RTD3 is created. RTD4 equal to RTD3 dot RTD3 dot map, right? RTD3 dot map, some mapping operation. So in this way, RTD5 RTD4 dot group by, or some group by operations, group by key. Finally, if I say RTD5 dot collect, this is collect is an action, then only the entire flow is going to get executed from the root RTD and gives the result, right? Where the RTDs are stored, where all these 5 RTDs are stored. What is your answer? Where all these 5 RTDs?
RAM.
Where all these 5 RTDs are stored means?
Memory. In memory.
How many RTDs in the RAM? Before that, how many RTDs in the RAM? How many RTDs in the RAM?
One.
How many RTDs in the RAM?
Before performing action, there is no RTD in the RAM. Only when we perform any action, they are loaded and like executed.
Zero, right? How many RTDs are in the RAM? Is 0.
0.
Where all the 5 RTDs are stored? Okay. RTDs are loaded one by one. RTDs are loaded one by one when action is performed. Right? So all the 5 RTDs won't be stored. One by one RTD gets loaded when action is performed. Observe this diagram, right? Observe this diagram once, right? R1, ODD1. The output of this RTD1 is taken as the input. The output of RTD1 is taken as the input by RTD2. You got some 100 records or 1000 records, right? Yes. When RDD2 is ready, when RTD2 is ready, RTD1 is removed from the RAM. The output of this RTD2 is taken as input. The output is taken as input by RDD3. Now on this RTD3, you are performing some kind of filtering operation, right? The output you will get, the output you got as 50 out of 1000 records, the output you got like 500 records. When RTD3 is ready, RTD2 get removed from the RAM. Now RTD3 only present within the RAM. Now RTD4, when RTD4 is ready, when RTD4 is ready, then RTD3 removed, then RTD3 is removed. RTD4 is ready, RTD3 is removed from the RAM. Next, RTD5 from R4, RTD4, RTD5. RTD5 is ready, RTD4 removed. Finally, this is the output. So this is the output, right? This is the output. After computation, when computation of RTD5, after computation of RTD5 will be removed from the RAM. Now what is present within the RAM? Nothing, right? How many RTDs in the RAM? Nothing, zero.
So Vijay, RTT5 you said, right? Like RTT5.collect if we perform that action. So you mean to say that after we perform that action, again if we use RTT5.collect, right? So you mean to say that we don't get the data back?
Once RTD5 collect, right? No RTDs, no date, nothing is available.
Okay, but
Once
if we want to use that in some other place, then again we need
persist.
Okay.
There is a concept of persistence, right? Persistence.
Okay, good.
Now, what do you mean by lazy evolution in Spark? Where all the five RTDs are stored means the five RTDs are not stored anywhere. RTDs one by one they get loaded and they will be removed, right? Yes. What is lazy evolution? Lazy evolution in Spark. What is lazy evolution? Is lazy evolution or active evolution? Lazy evolution means
as and when we need to execute a RDD, only then it will be executed.
on demand we'll execute them.
Yeah.
On demand we perform. On demand we execute or we perform. By performing an action on demand we execute them.
Only then it will be executed. Yes, on action.
Active evolution means whenever defined immediately should be executed. X equal to 10, immediately it should be executed, loaded, executed. But lazy evolution means, for example, if you are making notes now, it doesn't mean that you will immediately read it today itself. You will read after 1 week, after 1 month, after 2 months, right? Means that is when required, when exam is kept only you will read, right? Means that is lazy evolution, means whenever required only you will read. Here also when required only you will perform an action, just like functions, right? If you make a function call, then only it executes when required. In the same way here also, whenever you perform action only, then only it executes. Okay. What is lazy evolution in Spark? And the entire steps in RTD computation. Steps in RTD computation, right? RTDs initially all the RTDs are declared. They are not stored anywhere. They are going to get loaded one after the other. And once one is ready, the previous one gets removed. When action performed, flow execution will start from its root RTD. During the flow execution, each RTD partition's data will be loaded into RAMs and computed at RAMs. Steps in RTD computations, right? Observe. Step 1. Observe the step 1 from the whatever discussions we had, whatever observations we made. Initially, step 1 means initially all the RTDs are declared. They are not stored anywhere. They are not stored anywhere or not computed, right? We load them and execute them. We load them and execute them on demand. All the RTDs are declared, they're not stored anywhere, not we load them and execute them on demand by performing a action, performing an action. This type of evolution, this type of evolution is called as lazy evolution. And as we load them and execute on demand. This type of evolution is lazy evolution. Executing on demand, executing what do you mean by lazy evolution? Executing on demand by performing an action. They are not loaded. See here, initially the RTDs are just declared. When they will be loaded or computed means when action performed only, then they will be loaded. Otherwise, they are not loaded. Executing on demand by performing an action. You are writing the program code. Means RTD means it's not a ready-made object. We are going to create it by writing the program code. sc.text file, sc.text file, right? For context.text file, RTD1 is created. How RTD1 is created? sc.text file. Then RTD creates. Whenever you are loading a file, then RTD creates. Step 2, observe this step 2, right? When action is performed, observe this step 2. When action is performed, flow execution, from where it will start? When action is performed, flow execution will start from its root RTD or available RTD. Observe this step 3. During flow execution, during flow execution, each OTD partition data will be loaded into RAM and computed at RAM. Okay, fine. So initially the OTDs are declared, they are defined, they are not stored anywhere, means they are just, we are writing a code. Once then the RTD going to get created based on the statements we write. And step 2, when action performed, the flow execution will start from its root. Step 3, that during flow execution, each RTD will be loaded into RAM and computed at RAM, right? Yes. So more steps are there, step by step. Clearly, I'll be showing you. And tomorrow, mostly my discussion will be on persistence. So persistence means making the RTD available in the RAM, even though the next RTD is ready. Means so that it can give output to the other flows, right? And the various persistence options, the other things, right? Yes. Yes. Tomorrow also, everyone, you can attend the session to see more on this, right? Same time, we'll start the session by 5:10, right? 5 o'clock, but we'll start by 5:10, right? Yes. 5:10 to 6:10. Okay, for today, I'll stop here. We'll continue tomorrow. More discussion on this, where I'll discuss more on this persistence of an RTD. Which RTD will be persisted? What are the various persistence modes? Okay. So from next Monday, a Hadoop batch is going to start. If anybody wants to join with Hadoop, like so. Meanwhile, this week, next 2-3 days, I'll be discussing on this Spark and the Spark related things, right? Fault tolerance mechanism, how this persistence options, the other things. Later, I'll go for the next 2 weeks or 15 days, like on Scala programming. Next Monday, think like at 7 p.m. there is a Hadoop batch going to start at 7 p.m. So those who wants to prefer, you can just go for Hadoop.
Sir, Hadoop 1 month, sir.
Okay, so those you can attend, if you want, you can attend Scala here. Once you pay for Hadoop Spark and Hadoop and Spark, right? You can attend any Hadoop or any Spark batches of mine, right? 7 p.m. It will be at 7 p.m. right? Yes. Okay, fine. So I'll stop here for today and meet you tomorrow, like same time, right? To see more on this, right?